Let's discuss questions 8 and 9 of the 2025 General Maths paper. Here Declan depreciates the value of his lighting equipment using flat rate depreciation. So when you see flat rate depreciation, you've got to actually be extremely careful about the concepts that you use because it's very different from reducing balance depreciation. Now this graph shows you the value of the lighting equipment after n years. So you've got to be mindful about what the graph is also showing you. The value of the equipment can be modeled using a recurrence relation or a rule. So the word relation can also be replaced by a rule. Now a recurrence relation consists of two parts, and the starting value and the rule. Of course, some people write the rule and the starting value, but usually it's the starting value comma the rule. So here the starting value of the equipment was 40,000, and that's what you write first, comma. The next value, because this is going yearly, the next year's value, which is this, is equal to the current year's value, Vn. And if you look at what it's depreciating by, the value 40,000 minus 32,000 is 8,000. 32,000 minus 24,000 is also 8,000. And because it's going down by this constant value of 8,000 at the end of every year, this is your depreciation. And that is your recurrence relation. Write a rule for the value after n years. So this is value after n years. And this is different from the recurrence rule, which is a yearly rule, whereas Vn, which is also called the explicit rule, is the value after n years directly when you want to calculate a value. So it's written as Vn, and obviously the value depreciates. Now if you're going to calculate the value after n years, and every year it goes down by 8,000, the value in n years, the depreciation will be 8,000 times n, and you got to subtract that from its starting value, which is V0. And so its value after n years is Vn is equal to V0 minus 8,000 n. So you've got to replace this value. What is the annual flat rate depreciation percentage? So you've got to be mindful of the fact that they're asking you a percentage. Now, if they're asking you a percentage, that means that you got to multiply something into 100. And what is that? It is the depreciation. So you know that, so the rate percent of depreciation is the depreciation over the original value times 100. So we know the depreciation is 8,000, and its original value, it started off as is 40,000. And so 8,000 divided by 40,000 times 100 is 20%. Let's look at question 9. He now takes out a new loan of 50,000 to promote his new film. Interest on this loan compounds weekly. So we know that if it compounds weekly, there are 52 weeks in a year, and the payment per year and the compounds per year will be 52. And he makes weekly repayments of 75. So that's my PMT on the financial solver. With these weekly repayments of 75, suppose the balance of his loan does not change over time. So the balance of his loan does not change over time implies that his payment is equal to the interest earned, If that was the case, determine the weekly interest rate. Now, in order to calculate the repayment, which is equal to the interest earned, the formula would be interest is equal to the rate, because it is on a weekly basis. You got to include the p-value, the number of times it's calculated per year, times 100 of its original value. And so here, they've asked you the weekly interest rate, but what I'm calculating here with this formula is R over 5200 where P is 52 times 50,000, because that's the value of his loan, B naught, and that helps you calculate the interest, which is what he repays per week. So calculating R, it gives you a value of 7.8. Now 7.8 is a rate percent per annum. So in order to calculate the weekly rate, you divide by 52 and you get 0.15%. So be extremely mindful of whether they're asking you the weekly or the monthly interest rate or the rate per annum. With these weekly repayments of $75, suppose the balance of the loan now reduces over time. So this becomes a reducing balance loan. And the balance of the loan after n weeks, Ln, can be determined using a recurrence relation. So this was the value of his loan, initial loan, the recurrence rule. And the next value is calculated by the interest. So that means 1 plus R divided by weekly. So that's your R value, the current R times the current value minus 75. And this is his payment. Assume there are 52 weeks in a year. After 1 year, he owes this value. Determine the per annum interest rate compounding weekly as a percentage, correct 2 decimal places. Now, you can calculate this on your financial solver. Because it's after 1 year, n is equal to 52. It's a loan, so the principal value is plus because money comes to him. So anytime money comes towards a person, that's positive. And if money leaves your hand, it's negative. And so you leave a blank here because the interest is the question. And the per annum. So when you calculate on the financial solver the value for I, it's always interest per annum. And they say the payment that he makes is 75. Now because money is leaving him, he's making a repayment, so it's always negative. And after 1 year, that is 52 weeks over here, the future value is 49,565.34. And the payments and the compounds per year is 52. And when you tap on I, you get the value 6.96 followed by 5 zeros, 26, which is approximately 6.9%. Now here they have said rounded to 2 decimal places, so you should be writing 6.96%. What you have to be careful in this question is to put the future value as negative, because this is money that you still owe and which should be returned. In other words, money should leave you. Find the value of R rounded to 4 decimal places. Now we have the interest per annum as 6.96, and so the value of R rounded to 4 decimal places would be 1 plus R is 1 plus R over P times 100, which will be 1 plus 6.96 over 5200, and that approximately gives you 1.00133384, and correct 4 decimal places is approximately 1.0013. Question 10 is an interesting question. Using profits from his recent film, he invests. So this is an investment into a 10-year annuity. The annuity earns interest compounding quarterly. So this is BYCY is 4. And this is I. He invests, so money leaves him, and so that's minus PV. Declan receives a regular quarterly payment from the annuity. So we don't know what the payment is. So that's a question mark. Halfway through the 10-year annuity, he writes a recurrence relation to represent the quarter-to-quarter balance for the remainder of the annuity. Let Dn be the value of Declan's annuity n quarters after the halfway point. Complete the recurrence rule. So after the halfway point, if it's a recurrence rule, you need a starting value and a rule. And this is the rule. Now, in order to know what the balance is after the halfway point for the remainder of the annuity, so we got to calculate what the future value is after 5 years, because it's 10 years in total. So in the first 5 years, the interest is 6.4%. It's quarterly. Now we've got to find the future value. So using the financial solver, because it's quarterly, firstly, what we are not familiar with is what the regular payments are. So we calculate for the whole 10 years, 10 times 4. I is 6.4 given. The principal value is minus 650,000 because he invests money into an annuity. And the future value is 0. PYCY is 4. And so the regular payment works out to be this value. Now, knowing the regular payment, which is this, we calculate what the future value after 5 years would be. Okay. So I is 6.4, principal value is still investment, so minus, money leaves him. Payment that he is, now in an annuity, when you invest money, you get regular payments. So because you get regular payments, the payment that you get, is positive. So here, that's where you've got to be really careful. And then the future value, as you can see over here, is the value that 376,159.4283. And that is the balance after 5 years, which they are asking you to write as a recurrence rule. So whatever you see on your calculators should always be written in your calculation if you're asked, and that then should be rounded off to the value they want. So this rounds off to 0.43, and we write that as D0 over here. Now the rule is Dn plus 1 is equal to 1.016, which is the R value which they've given you, times Dn. And what is it that the repayments are to be written here? Sorry, it is not the repayments, it is the payment to Declan, because it's an annuity. This is the payment made to him regularly, made to him every quarter. And the payment made to him every quarter is going to reduce the value of his annuity investment, though it's increasing in value due to interest that it's earning, but because the payments are being made to him, it will reduce in, so it's going to be a minus, and the value that we calculated as the payment over here is going to be written over here. So you've got to be extremely careful about the positive and the negative signs in this question. It's quite simple if you don't confuse yourselves too much. Thanks.